Hey everybody, hope you're doing great. Please check out the description box for all the nice links. Drop a like, subscribe, hit that bell icon if you like the content. Check out the top right eye for more nice links. Today is all about the AI component and I'm really hyped about this. I've been playing around with this a little bit. So first things first, let's remove the little A that we can find in our AI follow.cpp. Everything should work, and I want you to just build this once just to see if it's working or not. So it seems to be working. You just move around here so we don't have any bugs. Now look at the enemies. They're spawning, but they're all stationary. This is what we want to start off with. Today's first step is going to be to actually add a follow to our player or to our enemy and make sure it can follow our player. So we have a few things we have to set up here, and I want to start you guys off with the enemy system. Now I have a lot of files here, don't mind everything else. Just look at the enemy system.h and cpp. The way this works is that in game state we create a new enemy system, and this is then used in the tile map to spawn enemies from the update function there. Now what I want to do is I want the player to be accessible to each enemy when the enemy spawns, so that the AI in the enemy can have access to the player as well. This can be a little daunting sometimes, especially in C++, where you can have circular dependencies and things like that. I'm sure you guys have had problems with that in your life. If you want to work without that, I'd recommend working in something like C#. But anyway, we have that issue here. But let's go ahead and start here in an enemy system. Let's send in our player, and you're going to be like, what? We haven't done anything. Why are you sending it in? Well, we're going to do stuff. We're going to do some mad, nice, swaggy stuff. So look at this. We have our player in here. It's going to be sent in. So open up your enemy system.h, go down here anywhere you like, anywhere, it's your world here, anything you like. I just want you to write entity reference player. This is what I want you to write. Now you can do player entity if you want. You can come up with a cooler name. I'll just say player so I know what's going on. I'm gonna make sure the enemy system always has access to the player. So let's do that. Let's make sure we create a player parameter to send in our player to. Once you have that in the header, go ahead into your CPP file for enemy system and do the same thing here in the constructor. So you'll have your constructor up here, of course. Just go ahead and do entity player like that. And it will ask you, of course, to do this here, player. Player's not harder than that. Now we have a player reference constantly accessible to any enemy, anything in our enemy system. This is a beautiful way to handle this, I think, at least. I really like this way. Now, of course, if we were in C#, we wouldn't have this issue in the same sense, but we have to work with the constraints that we have. Make sure we send our player into our new rat here as well. Now, again, you're going to be like, what? Why are you sending this in? We haven't set it up. But wait, bro, wait, we are setting it up. So we're sending in player here. It's not going to work, obviously. Make sure your enemy system, of course, has everything set up correctly. Make sure you can run it from here. Probably, if you don't add this, you can make sure you're running it. Always run your applications constantly to see that they're working. Anyway, let's go from here, player into rat. So what do we open? Well, we have to open our rat.h. All right, what I would like to do is actually add that to our enemy directly, so that we can come to a little later. But what I want to eventually do is add a player entity always accessible to an enemy, but that doesn't really always make sense to me. What we can instead do is send it into our rat where it's needed. So let's go ahead and do that. First, go to rat here, paste that entity reference player here, and then you want to do the same thing in the CPP file, entity reference player. Once that's done, you're good to go. You have a player coming into your rat entity here. What I will do is I'm going to initialize the component for the AI using the player. I'm not going to keep a constant reference to the player and enemy. I don't like that really. That doesn't really make sense to me. What I want to do is the AI component, the one that requires it, will keep the reference to the player entity. Now, good thing is, just to remind you guys, is our entity class holds all the components, all the sprites. So our player, everything our player has is accessible through this entity, the player's entity. So we don't have to send in the player class. We're just going to send in this base class called entity, and it's much better. Once that's done, you send in your player here, of course. Let's go ahead and check up on our follow.cpp. We have an error here, a problem here we have to fix. That is my calculation, because I'm a math noob. So we're gonna switch places on this these get position x for the entity, which is the player then, and the self, which is the enemy in our case, So we're just going to switch these over like this. Make sure you're doing this right with the minus, and make sure to remove this minus here. Otherwise, you're going to have some problems. Once that's done, this will then calculate a normalized vector towards the player from the enemy. And this will look really cool when this works. Trust me, guys, you're going to love this. Let's go ahead and just try it out. Let's go to our rat.cpp and see whatever we're doing here. I'm just going to go ahead and write straight up, just do it here. This, let's see. Oh, we got to create one of those. Sorry about that. Let's create follow. Let's create a follow here in our rat AI follow pointer follow. And of course, we're going to have to include AI follow.h. Now we have a pointer in our CPP file. We're going to say this follow equals new AI follow like that. And then that would be the player. So we're just going to send the player. Remember, you have your player reference coming in here, but you need to dereference this because this is the pointer to oneself. So this rat itself. So that's why it's a pointer. You want to convert that to a reference. For that, you need to dereference it. Don't forget that. I could give you some errors. Once you have this, you have a follow AI basically. You can use this and we can update this right here and it will show directly pretty much. So this follow update, and you just need to give it DT. And then you're good to go. It's not this DT, sorry about that, DT. I'm so used to writing this. Once you have DT set up, you will be good to go. Make sure you do a new and make sure you also delete it. So let's go to the rat destructor and just do delete this follow. And it's okay, we're just using this for now. We're not gonna do it like this. Once this is done, you will go into your enemy system. Everything seems fine, everything will be fine here. But game state, you might have to just make sure that you're sending in a dereference player here. Again, make sure it's dereference. And the rats will start following the player just like we wanted to. So this looks more like a game already, right? It's automatically following the player and changing the animation of the rats, which is pretty cool. This looks like a game to me now. I like this. This is cool. What's going to happen if you don't change the code for the follow, the vector, is going to be that they're going to be moving away from you because it will be a negative vector. It will be twisted around kind of. So that's why we had to switch the places right here. So the next step for us is a little fix, a little special treat for you guys. We have our vector length here. Now this is really fun. This is why we created this AI follow option, this AI segmented kind of AI, because here we can customize this specific AI behavior. For example, like this, we have a vector length, and that will be the length between the player and the entity, the enemy. So we can check that. We can do all this. We can move everything only if that vector length is a certain length or not. So let's do that. Let's do and here. Now let's put all this in brackets or parentheses. So of course, if it's not at that position yet, and if std abs vec length, so the absolute value, positive value of this, if this is greater than or less than a certain amount, I don't know how much that could be, maybe let's say 5f, then it's going to start following the player. Otherwise, it's not going to follow the player. So we have to increase this a little bit. 100 is even a little too little. Let's do 500 so they don't continuously follow you. So if you go out of the aggro range, you'll see they stop following you. But if you come close enough, they'll stop following you again. So we're going to play around with this and tune it a little bit. Let's prepare for the component itself. To do that, I want you to go to the entity section here, and we'll see we have a bunch of components here. Of course, we can't add one here yet because we haven't created the class, but what we can do is we can do a void create AI component. The idea is again to create the component for the AI here for any entity, and then you can just link entities together and create any kinds of AI that you want. So once you have this AI component create function completed, then we could just create the AI component class itself. So let's do that, class AI component, and you're gonna get some homework here. Guys, I want you guys to just think about how this component's gonna work and maybe come up with some more AI ideas for yourself, and just add them here if you want to. Play around with follow, try to make it cool, or try to tune it as much as you like. And I think that this is a great practice for you guys. This is a good way to do AI for basic AI, but there's more advanced ways to do this, of course. Private, let's do a private section here, and let's just complete the structure of this AI component here. Let's do a destructor AI component like we always do. Define these, define what are we gonna need in. Now my public section is above the private. I can't have that, guys. We're gonna have to do this. Good. And here we're just gonna have an entity reference player like that, or any entity, source entity or destination entity, sorry. And then we'll have the self entity here as well. Boom, very nice. We have to include entity as well. Include entity.h and include AI follow which is very important. So here are all the options are gonna be here, and we have the entity up here. Of course, we wanna place these correctly in our components folder. So go ahead and find those. It should be in the source files here somewhere. There we go, source files. Put it right in here into the component section. Just run this once. Let's see that everything is working fine. There you go. We need to set the references here before we can begin anything. So make a initializer list, say entity. We're gonna add these, of course. Self. And if you want, we can trade places on this. It makes more sense. Self first. Doesn't really matter. It's just my OCD here. Once that's done, let's do an entity reference self, entity reference entity. Copy the whole thing here and paste it into the header file, and there you go, you're good to go. Let's make a void update here as well, const float dt. These are all the things we're gonna have to use in the coming videos here. Define this as well, and then it shouldn't complain if you run this. Good, now you have a nice shell ready here, but the follow thing is working. That's pretty cool. Play around with that, guys. Thank you for watching. Drop a like, subscribe, and hopefully I'll see you in the next one. Bye bye.